In the second part of section 5.5, we will talk about the rational zeros theorem. In the first section, we were given the zeros, and from there, we built a polynomial. In the second part, we will be given a polynomial, and we will have to find the zeros of that polynomial. For example, we want to find all the zeros of the polynomial 4x cubed plus 8x squared minus 17x minus 30. Now, before that, let's list out all the possible zeros that this polynomial can have. Now, the rational zeros theorem says that if you have a polynomial in this form, then all the possible zeros are going to be in the form of p over q. So any possible zero is going to be in this form, where p is a factor of the constant a sub 0, and q is a factor of a sub n, which is the leading coefficient. Okay, so in this case, p, this is going to be a factor of the constant, and q is going to be a factor of the leading coefficient. And any possible zero that f of x can have is going to be in the form of p over q. Okay, so in this case, we want to list all the possible rational zeros of this polynomial. So all the possible rational zeros are in the form of p over q. Now p is 30 and q is 4. So p is a constant and q is the leading coefficient. So by this, we want to list all the factors of 30. So all the factors of 30 are, start with 1. 1 can divide 30. 2 can divide 30. A factor is any number that can divide 30. 3 can divide 30. 4 cannot divide 30. But 5 can divide 30 and 6 can divide 30. And that's it. Oh, I take it back. That is not it. 7 cannot divide 30. 8 cannot divide 30. 9 cannot, but 10 can divide 30. Let's see, 11, 12, 13, 14, 15, and 30. So basically, it's like this. You got 1 times 30, we got 2 times 15, we got 3 times 10, and you got 5 times 6. So those are all the possible factors of 30. If you want a more simple way, take 30, start with 1. We got 1 and 30, we got 2 and 15, we have 3 and 10, 4 doesn't go into it, and you have 5 and 6. And I have 1, 2, 3, 5, 6, 10, 15, 30, and that's what we have. So those are all the factors of P. Now let's list all the factors of Q, and Q in this case is the leading coefficient, which is 4. So for 4, our factors are 1 times 4 and 2 times 2. So it's just going to be 1, 2, and 4. Now the ratio P over Q is going to look like this. Now each of these could be a plus or a minus, so it's going to be plus or minus 1 over 1, which is 1. So now take the first number and divide it by each of these. So we got plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4. Then let's go to the 2. So we have plus or minus 2 over 1, which is 2, plus or minus, now 2 over 2 is 1, which we already have, so we don't have to write that twice. 2 over 4 is 1/2, which we have, so we don't have to write that twice. Now let's go to 3. So 3 over 1, that's going to be plus or minus 3. 3 over 2, that's going to be plus or minus 3/2. 3 over 4, that's going to be plus or minus 3/4. Now let's go to 5. So we got 5 over 1, that's going to be plus or minus 5. 5 over 2, that's going to be plus or minus 5/2. 5 over 4, that's going to be plus or minus 5/4. Now let's go to 6. We have 6 over 1, that's plus or minus 6. 6 over 2, that's plus or minus 3, but 3 is already there. 6 over 4, that's plus or minus 3/2. 3/2 is also there, so we don't have to write those twice. Then let's go to 10. We have 10 over 1, that's plus or minus 10. 10 over 2, that's plus or minus 5. 5 is already here. 10 over 4, that's plus or minus 5/2. That's also there. Then we got 15. So we have plus or minus 15 over 1, that's 15. Plus or minus 15 over 2, that's not there, and then 15 over 4. Then we have 30 over 1, that's going to be plus or minus 30. Then we have 30 over 2, that's going to be plus or minus 15. And then we have 30 over 4, which is 15 over 2, and that's already there. So these are all the possible zeros of this polynomial function. Now notice that these are all the possible rational zeros. If we were to do this by hand, here's what would happen. We would have to set up synthetic division and test each of these to see which of those gives us a remainder of 0. because once we get a remainder of 0, that we know that that number is a 0. So we would have to set up synthetic division, which would look like this. So we would have 4, 8, -17, and -30, and then start with like 1 or -1, and literally test every single one of these until we get a 0 remainder. That could take forever. So we're not going to do that. We're going to use a shortcut because we have technology. So in order to, so these are all the possible rational zeros. The zeros are somewhere amongst these. Okay, so here's how we're going to find the zeros. We're going to use Desmos. So finding zeros of rational functions, step 1, graph f of x on Desmos and find the rational zeros. So what we're going to do is we're going to graph this. And I had the picture here for you guys, but what you would do is you would go to desmos.com, and I've already done this. You would graph this, you would put in this polynomial, and you would see its graph. Then you're going to locate all the zeros. Okay, so now let's go with the zeros that that are like whole numbers. So for example, 2 is a 0. So what we're going to do is we're going to say, since 2 is a 0, we know that of this list that we made of all the possible zeros, instead of testing all these out one by one, the graph tells us that 2 is going to be a 0. So now that we know that 2 is a 0, which is right there, and remember, a 0 is any number where the graph crosses the x-axis. So let's go with the whole number. We know that 2 is a 0. So we did that. So one of our zeros is going to be x equals 2. Then we are going to use synthetic division by the rational zeros until the depressed equation, which is the result, is a quadratic. So let's go ahead and do that. Let's set up our synthetic division, which is we got the coefficient of x cubed is 4, coefficient of x squared is 8, then we have -17, and we have -30. Now remember, if one of the exponents was missing, you would have to put a 0 in its place, but here we have everything. And we know that x equals 2 is a 0, so I'm going to do synthetic division by 2. Okay, so let's start. Bring the 4 down. 2 times 4 is 8. I put the result there. 8 plus 8 is 16. 2 times 16 is 32. I put the result there. That's 15. And 2 times 15 is 30. I put the result there, and that's going to be 0. So this is called the depressed equation. Now we started off with x cubed. We divided by a factor of x. So this is going to be 4x squared plus 16x plus 15. And there's a remainder of 0. So when we have a depressed equation that's a quadratic, that's good because we know how to solve quadratic equations by either factoring or the quadratic formula. So we have 4x squared plus 16x plus 15 equals to 0. Now we got to factor that or use a quadratic formula. Take your pick, but we have to solve that equation. I'm going to factor it. So when I factor, I'm going to take 4 times 15, which is 60, put that on top. I'm going to put 16 on the bottom. I want to find two numbers which will multiply to be 60, add up to be 16. Those are going to be 10 and 6. Be careful, don't just put x plus 10, x plus 6, because we have a 4x here. So the method I taught you guys is you ignore the exponent and just put a 4x on top of each of these and then reduce it. So if you reduce the 4x divided by 10, this gives you 2x over 5. You divide by 2. You reduce 4x over 6. This gives you 2x over 3. So and now these fall over, so we got 2x plus 5 times 2x plus 3, and that is equal to 0. Now to solve, we set each equation equal to 0 by the zero product property, so we're going to get x equals to -5 over 2 and x equals to -3 over 2. So all the zeros, and because it's a degree 3, we're going to have 3 zeros. So we have one of the zeros is 2, one of the zeros is -5 half, and one of the zeros is -3 half. Now -5 half, this is, -2.5. -3 half, that's -1.5. And if we go back to our graph over here, there we go. We got -2.5, -1.5, and 2 as the zeros. So basic steps are graph this on Desmos, identify 1, 0. If it's a degree 3, if it's a degree 4, you'll have to identify 2 zeros, but it's a degree 3 because so we identify 1, 0. And the reason for 1, 0 is when you do synthetic division, we go from a degree 3 to a degree 2. And what we want is a quadratic, so we can use a quadratic formula or we can factor it. Let's take another example. We have a degree 4 polynomial. So this one I'm going to go through a little bit more quickly. I want to find zeros that are whole numbers. So like this one here, that's a -1, and this one here, that's a -3. I'm not going to pick these other ones because they're like somewhere in between. So I know that x equals to -1 is a 0, and x equals to -3 is a 0. But if you graph this on Desmos, it'll become much more clear. Okay, now let's do synthetic division until we get a depressed equation that's a quadratic. So let's set this up. We got 1, 8, 21, 20, and 6. And it doesn't matter which 0 you start with. I'm going to start with a -1. Okay, so I bring the 1 down. -1 times 1 is -1. 8 minus 1 is 7. -1 times 7 is -7. That's a 14. -1 times 14 is -14. That's a 6. -1 times 6 is -6, and that's a 0. If we did it correctly, the remainder is always going to be 0. Now use that depressed equation. We went from a degree 4 to a degree 3. We want to get it down to a quadratic. So use that depressed equation and now take -3 as the 0. Okay, so let's do synthetic division by -3. So we bring the 1 down. -3 times 1 is -3. That's a 4. -3 times 4 is -12. That's a 2. -3 times 2 is -6, and that's a 0. So our quadratic is going to be x squared plus 4x plus 2 equals to 0. Now we have a choice. We can factor this or use a quadratic formula. Always try factoring first because it's easier. So here we got 1 times 2 is 2. Our middle term is 4. But no numbers multiply to be 2 and add up to be 4. So we can't use factoring. We have to use a quadratic formula. For the quadratic formula, the value of a is 1, the value of b is 4, and the value of c is 2. So our quadratic formula is going to be -4, which is -b, plus or minus the square root of b squared, that's 4 squared, minus 4 times a times c, and all of that divided by 2 times a. Make sure you use a parentheses anytime you replace a variable with a number. So this gives you -4 plus or minus square root of 4 squared is 16, minus 4 times 1 is 4, 4 times 2 is 8, divided by 2. If I keep simplifying, that gives me -4 plus or minus the square root of 8 divided by 2. Quick reminder of how to simplify square roots. We have a square root of 4, or sorry, square root of 8 rather. And when you split this up, you have to split this up so that one of the numbers is a perfect square. So that's you can use 4 and 2. The 4 comes out, and this becomes 2 radical 2. So this becomes -4 over 2 plus or minus 2 radical 2 over 2. And remember to separate these and divide by the 2. So the radical 8 is 2 radical 2. So we take -4 divided by 2 plus or minus 2 radical 2 divided by 2. Now let's simplify this. -4 divided by 2 is -2. Here we got 2 divided by 2 is 1. So we get plus or minus radical 2. So our zeros, and there's 4 of them because we have a degree 4 polynomial, our zeros, which we have to list out, are going to be -1, -3. Those are our rational zeros. And then we have -2 plus or minus radical 2. In my open math, you might have to list those out as -1, -3, and then -2 plus radical 2 and -2 minus radical 2. So in my open math, I think you're going to have to list these out as -1, -3, -2 plus radical 2, and -2 minus radical 2. So those are our 4 zeros. All right. Okay. The next one we will do in class.